Years and years ago, the wife and I were driving to a movie down Culver, which is divided with a bunch of poles, and the idea hit me. But the idea was stimulated by a flyer we got from the mayor of Irvine talking about a $120 million light rail project for Irvine, which seemed like a ridiculous amount of money 20 years ago. And I kind of figured this out based on my previous experience with the streamlined bikes and the California Commuter that, wow, we can move a lot of people around very fast with aerodynamic little vehicles, low power. And I think I was up till 2 at night after that movie doing a lot of math and calculations, because that's what this all boils down to. We kind of call it the physical internet. And it will be silicon-based transportation. Silicon is something different. We will have little vehicles, 2-passenger tandem vehicles, very streamlined. Neighborhood speeds 35 miles an hour, major arteries 100 miles an hour, intercity 150 miles an hour. And they have to be MagLev. You can't have little vehicles with little wheels and gears. You know, there are other personal rapid transit systems, but they're limited to about 35, 45 miles an hour. And if you get a lot of utility out of those, say you're putting on 60,000 miles a month, you're changing tires and gears out all the time. It'd be a maintenance nightmare. MagLev, nothing is contacting. There is no wear. So we have to be MagLev, we have to be very small frontal area and very streamlined. And we're talking about equivalent of 200 mile per gallon efficiency in terms of energy costs. And no fossil fuels to burn, totally non-polluting. And these things are small and light enough that all of a sudden we're discovering we can afford to have them solar power. That, in other words, solar is very expensive, but if you had a train, you couldn't even create enough power to move 1 million pounds, but when you're talking a 200-pound vehicle with, say, 500 pounds of payload, solar becomes pretty practical. So we may be a total non-grid powered system of the future. Solar-powered SkyTran, the solar can be anywhere, ideally somewhere out in the desert. Okay, you just have to look at the cost to install it. There's new nano solar, which apparently is going to cut down the cost of solar by a factor of 10. And then they're saying when we figure out some new brilliant things to cut it down by another factor of 5, it'll be the choice for all kinds of power. But in the meantime, we've got to get rid of fossil fuels. And this is one thing that SkyTran enables, is getting rid of fossil fuels and moving people around fast, everywhere, nonstop. SkyTran runs up in the air on elevated, we call them micro freeways, guideways. They're trapped, they can never derail. They're up above all traffic, so you don't have to worry about hitting pets or potholes in the road. There's no such critters. No, you can't hit kids or other people. People are finally becoming aware of the automatic braking systems for cars that have been around for 10 years, and we've been talking about that for SkyTran forever. You need that. So if it senses something happen to a vehicle ahead, it'll just stop automatically. Okay, SkyTran has the potential to eliminate commuter congestion totally in a city, and that's mainly because of cost. You can, compared to a light rail especially, you can afford to put parallel guide. In other words, what's the best way to say the 405 freeway? Here, which is a jam, here you could afford to put the 406, the 407, the 408, the 403, the 402, 401 parallel, and then another set of freeways, micro freeways, perpendicular, and then these are all interconnected. So now just think if you normally get on the 405 and it's fully congested, but you could go on the 404, the 403, or 406, 407, all of a sudden your traffic is way down. The other aspect I haven't pointed out is the SkyTran going 100 miles an hour with the automation factory type separations that are very, very common these days. We can carry more on one little rail with these 2-passenger people than a 3-lane freeway per hour. So that's why we use this freeway analogy, and these are very low costs compared to freeways or especially to light rail. We don't need a high density around our stations as does light rail to justify the cost, because our costs are minimum compared to that. So we can actually put SkyTran anywhere, in any little neighborhood, out in the boondocks. The big advantage when we're talking intercity, comparing to the big trains, is say you're going Frisco to Los Angeles. So how many stations are you going to have? You might stop in, depending on the route, Merced, Bakersfield, Fresno, I don't know. But here, right in San Francisco, you could have 200 stations along that route, so people could conveniently get on, and the same with LA. And once you build the grids out in LA and San Francisco, you can go anywhere and get to LA. You could afford to go up there for an evening dinner and get home in a reasonable time too. There is a problem called the last mile. In other words, if we're on a 1 mile by 1 mile 3D grid in a city and got the city covered, the average person has to walk about 5 minutes to get it with any place within that grid. That's because we cover a city. Now, light rail, you might have one linear line in a big city. So you might have to travel 4 or 5 miles to get to that light rail, to go 15, 17 miles an hour somewhere. And then when you get off, are you going to be at your place you want to be, or do you have to travel another 3 or 5 miles? And this is the intermodal, where you hop on a bus, hop on the light rail, and then hop on another bus to get where you really want it. For light rail and things like that, it's not a last mile. It could be a last 10 miles. With us, it's a last 600 steps that you have to worry about. And we have cool inventions, which we can't tell you about, but how about 5-pound fold-up scooters and things like that that have enough range to get you there. And there's all kinds of solutions for this. And eventually, once the SkyTran really takes off, it'll probably end up going right into people's houses, and you'll be able to, maybe you'll have 1 car, you won't need 3 cars in a family anymore, and this will kind of change the whole thing, but that's way off in the future. The same SkyTran technologies for linear synchronous motors and the MagLev are being applied to wind technologies. What we're doing with our partner One Cycle Control and power conversion, there's a couple aspects of this. We are, number one, we're building a unit here in Irvine to go up in Palm Springs to replace a 1980s Norwegian 58-foot diameter windmill, 65 kilowatts. This should be going up in a couple of weeks, and we'll have to test it for a couple months, and then there's going to be several hundred if they like the data they see. In other words, we do all this math and physics, but now you got to build stuff and prove it, so that's what we're doing. So this technology, we will eliminate the gearboxes. We have a direct drive system. 40% of the lifetime cost of windmills is the gearboxes. They wear out. The same reason on SkyTran, you don't want gearboxes and tires. Things wear out. The other aspect is the power conversion. We can take low speeds and high speeds and supply to the utility, Southern California Edison in this instance, proper frequency electric. In other words, if all your frequency is 60 cycle, maybe they can accept between 50 and 70. Well, if their grid is being pulled down to say 59.3 cycles a second, guess what we're going to deliver? 59.3. And this is the One Cycle Control power technology. What this enables is we can gather energy at very low speeds and higher speeds, up to the limitations where you have a good structural safety factor on the props. We, side by side, the geared type system compared to our system, in a year we should be able to sell about double the energy to Southern California Edison on the same wind profile on the same hill. This is going to be pretty hot. We're getting a lot of interest and financial interest in this technology. And it really actually gets better when we start talking 3 or 5 megawatt windmills, the big ones. And there's even 10 megawatt windmills up being designed now too. When you pass a magnet over a wire, it induces a current in that wire. If you run alternately, if you run a current through a wire, it creates an electromagnetic field. So if you have a whole bunch of coils and you start passing some magnets over them, which are in this vehicle, and you design this all correctly, it'll actually start lifting the vehicle off. There's a repulsion and it's stable. So now what happens if you lose the power to propel the vehicle, you do not lose the magnetic levitation, the passive magnetic levitation, so it's super safe. With 7 pounds of lithium polymer backup batteries in our vehicles, say we're going 100 miles an hour, and we lose all grid power, we can still go 3 miles, and we should have stations every mile apart, so there's a big safety factor with passive MagLev. And again, it's always had to be some kind of MagLev, because we do not want all the maintenance costs associated with gears and little tires wearing out, and we want the high speed capability. Like the Transrapid MagLev train that goes, what, I think 300 miles an hour in Beijing for a short distance, first one. If they lose power, they lose their levitation. You'd come to a screeching halt. They have to have all kind of like computer uninterrupted backup power supplies and things, so that never happens. And you know, you can design that. However, that is a huge train, very expensive, just ridiculously expensive, pretty fast, and very high maintenance. That because their MagLev is so critical in tolerance, they have to keep that track super aligned properly. Where ours is very tolerant, and our vehicles are small, so everything is cheap in comparison, a lot less expensive. That thing probably weighs 1 million pounds. In our little vehicles, at gross weight, it'll weigh 750 pounds. It's just we have a continuous stream of vehicles, and they have the one big vehicle. So they are flying, if you want to call it flying, every, what, half hour? In our case, if they're going 300 miles an hour, in our case, you'd get there, boom, you'd be on board and going. So you'd probably get there just as quick going 150 miles an hour if we replaced or put it side by side with the Beijing's Transrapid system. SkyTran is a much cheaper option or compared to light rail, because we're lighter, smaller, faster. We can move more people an hour, use a lot less energy, a lot less or no land basically. We can pop SkyTran onto sidewalks where they have to, they're 60, 70 million a mile. A lot of that is just buying up land, valuable land. We don't need to do that. We just need a 2-foot post every so many feet to build our system, and we can attach it to buildings. It's the advantage of going small. And they can carry so many people, but even if they're coming by once every 5 minutes or once every 3 minutes, once you have a continuous system with stations, convenience stations everywhere, you can carry a lot more people per hour. It's very close to the automobile. You know, why have we started loving the automobile? Because we can get places faster, cheaper, more conveniently. Unfortunately, the fossil fuels, everyone's starting to hate fossil fuels. It's just like, oh boy, back in the original days of this country, the Jamestown colony was ready to go back to England, and then all of a sudden they got a product that people would buy. Guess what that was? Tobacco. And now tobacco is an evil product, and fossil fuels are going that same way. And that was the second product that really made this country. World War II and everything, and all the technology based on fossil fuel. But now we're becoming more and more aware of all the total disadvantages of it, and it's getting to be like an evil thing. It isn't, but we will, with our little brains, figure out how to get around it. And SkyTran is one good way to do that. New Orleans is very interested. I've been to Sweden. Sweden seems to really understand what this type of technology can do for reducing energy requirements, moving people, totally eliminating traffic congestion. We also went to Abu Dhabi, my two business buddies, partners, and there have this carless city of the future Masdar being built. Now we didn't win that, and I was almost happy because they're talking like a 14-mile-an-hour system that's also going to carry freight and garbage and everything else like that. It's not my goal. My goal is the solving the commuter congestion problem and moving people around city, getting dad home early, a lot faster and a lot saner and a lot safer. We haven't talked about safety, but safety is a big issue when you start talking this kind of computer-controlled technology. Cities in the U.S. we're talking to, Santa Cruz is interested, Marin County, New Orleans looks very interested. NASA Ames, where we have our short little powered prototype, full-size prototype, is going to create a innovation university, and we may be a little feeder from the Caltrain to all over the campus there, which would be a good test thing. We'll be running 25 miles an hour for a year. And then, the next system will be the 35-mile-an-hour system, and we'll keep building that up. There's inquiries from all over. It's just how many are real. But we are looking into becoming like feeders for light rail. So here's my system, or going 40, 50 miles an hour in the beginning to feed a system that'll take people around at 15 or 17 miles an hour. We also make a lot of sense for the future for airports to take people right to their gates, and you pop in a luggage in another vehicle and it would take you right there. One of the real good future things is, say you're going to Florida. You get on in New York, you fly down to Florida, you've checked your baggage in New York, you never have to see it again. It's going to appear in your hotel. The Sky Tran micro freeway is so inexpensive, we could run it once you get off the airport in Florida to 50 different hotels. And you'd get out of your gate, within 200 feet, you'd be on the Sky Tran, boom, you'd be in your hotel you picked, and your luggage might already be there, or it might be there 10 minutes later. That's the future that I've always seen for this type of a system. We don't need their money. This should be a private enterprise. We just don't need the special interests protecting 1900s train technologies like it's the ultimate forever. Everything can be improved forever. We're trying to do that, baby. It is so logical. The computer technology, the aerodynamics, the composite structures, the control systems, just the user interface, it's all well understood. It could have been done 15, 10 years ago, easy. So it just takes a while for people to grasp it. They'll probably be scared of it for the first couple of years, and the teenagers will love it right off the bat, the iPhone kids. And little by little, it'll open up a lot of things. Younger people will be able to go places with ease. Older, more frail people who don't have driver's licenses anymore can go places. Emergency medical service, bam, 100 miles an hour into the emergency room directly when you have a problem. All kinds of things. You have to spend a lot of time understanding all the implications of what this kind of a transportation system can provide. SkyTran technology applies to many, many other fields, and especially with our partner who is now, we're all licensed and business official partners with certain exclusive licenses. One cycle control. We could even do lower cost access to space with electronics, with this power conversion system Greg Smedley and his genius wife Kay have come up with. We could build a small guideway up a mountain, say like in Hawaii. I wouldn't mind spending some time over there, more time over there. And if you look at a regular space vehicle, 50% of the fuel is used to get up to about 50,000 feet and 1,200 miles an hour. And we could be doing electric launches, okay, that would take payloads up to about Mach 1, a little less than 1,200 miles an hour at 10,000 foot elevation. And then they're working on supersonic combustion ramjets, and that's getting more feasible. And you can get out of 99% of the Earth's atmosphere, and then you finally have this little rocket that would boost your. These are microsatellites. These are not big space shuttle type vehicles. Then, while the cart, the dolly that carried this supersonic combustion ramjet up the mountain, build it up to speed, is coasting back, you actually are regenerating and capturing some of your energy. So it makes microsatellite launches very cheap. People, the aeronautical engineers like myself, have been looking at this as a method to launch stuff into space cheaply for years, but the electronic power conversion technology we have now is really making it look practical. It'll happen. I don't think the Segway is one, but I think Elon Musk creating that company to build the Tesla electric cars is one. He's also done SpaceX, and they have launched the first commercial liquid fuel paying payload ever in history by a commercial company. And he's getting ready to launch stuff, big stuff, Falcon 9, which will carry supplies to the space station, so we don't have to shoot billions of dollars to Russia. We can spend it here. And they're also going to do a man-rated capsule. Other mobility technologies out there, there are other what they call personal rapid transit systems out there, a whole bunch of people with ideas. But they're all 35, 45 mile an hour limited systems. They may work in the interim. High-speed rail, forget it. You can do so much more with this because you're not scheduled, you're on demand, you can just go nonstop to where you want. It's going to make a lot more sense. Airplanes, everyone wants to go Mach 3. You know, when there will be personal rockets to go from here to Europe, who knows? But some days we'll have the Star Trek goodies. Teleportation would be great. I don't know if anyone's really coming close to figuring that one out.